Hello student, welcome back to the sixth pre-video of our course Automata Theory and Computability. This new topic is a new topic for you people, and also it is very important topic as per as your exam point of view. You can expect some question on Epsilon Nondeterministic Finite Automaton, which is an extension of NFA only. It is not having any other extra feature as compared to NFA. It is only one symbol as included, as much as similar to the NFA only. Only thing is we will be using some epsilon over there. Is it very easier to construct as compared to NFA? Since the one flexibility is available is epsilon symbol, right? So whenever NFA having epsilon transition, then you can treat that as a epsilon non-deterministic finite state machine. So if there is no epsilon transition, but still it has a multiple transition on same input, in such transition diagram is called as a NFA. For example, I have to clear your doubt is more on Epsilon NFA and NFA. I'll take one of the example. So I have to clearly explain it. Suppose n number of A's such that n is even or divisible by 3. How do you construct this? So there is a two condition is there. N should be is even or it should be divisible by 3. N is even means, so what is a n? There is a n is 1, it is 0. Then n is 1, it is a only 1, it is a hard. N is 2, there is a even, right? That means it is accepting even number of A's. It is divisible 3 means then it may be 3, n is a 3 or 6 or 9. So then it accepting which is divisible a 3. There are two cases. How do you do that? I have constructed already. Look at this. I have taken P as a initial state. First you have to look the first case of n is even. As I told you in the introduction itself, whenever you want to change a state from one state to other state, if there is no input, still you can able to transit from one state to other state on epsilon symbol. So that is I have created. So here it is Q. Suppose n is 0, still move to this. So suppose A is even. Is it accepting? It is a even. A first it will come this, then it will go to A, come back. So even number of A's is accepting. Similarly, in this case, which is divisible by 3. Look at this. A minimum string is A. Similarly, it can 6A. A. Right? So first 3A is accepting. In second row also accepting 3A's. So that means finally reached to the final state only it is accepted. Only thing what I am going to wanted to clear here, you can satisfy the two condition. N is even. Suppose n is a even, it will go to this path, right? Or is n is divisible by 3, which will go to this path, right? Both the condition you can satisfy while constructing a epsilon NFA. So then you have to discuss what is the formal definition of NFA? Epsilon and DFA. Again, which is defined by 5 tuples denoted by M. The M is equal to Q, sigma, delta, Q naught, F. What is Q? Q is a set of states, is Q naught, Q1, Q2. Sigma is input alphabets, that is A comma B. Then Q naught delta is a transition function. Then you can write it like this: Q cross within the sigma union epsilon, it leads to the 2 raised to by Q, 2 power Q. Right, but epsilon is not member of sigma. Epsilon is not member of sigma. Right, then Q naught is an initial state, F is the accepting state. Then there is a note as given here. So note, epsilon is never a member of sigma. Need to remember it. It is not a member of sigma. One thing is here, similar point is noticed it. So this M or 5 tuples is remains same for all DFA, NFA, epsilon and DFSM. Only thing is there is a difference in only delta or transition function. So whereas in delta in DFA Q cross sigma, but whereas in NFA Q cross sigma to 2 power Q, but whereas in epsilon and DFSM or NFA Q cross sigma unions epsilon to 2 power Q, since epsilon will be included in this function. Okay, only that is a difference. So is it not a extra method in place of NDFSM? Is it as only sense of you are adding convenient transiting from one state to other state will using the epsilon transition, both will be accepting the same language. Both NFA and epsilon NFA are recognizing exactly same language. So it is not a different one. It is not a different than NFA. Both are accepting same. So there is only one. This will be the speciality of epsilon and DFSM. And one more terminology I am introducing now, that is E-closure. E-closure, it plays important role while solving a problems. These terms is very important. So why this is I'm emphasizing again and giving importance for E-closure. Without knowing the definition of E-closure is very difficult to convert from epsilon and DFSM to DFSM. So epsilon E-closure is a set of state which are reachable from Q without taking any input, then it is called as a E-closure. The E-closure of the state, suppose Q, which is denoted like this, E-closure of Q is a set that contains a Q together with all state that can be reached starting at Q, followed by following only epsilon transition. Right? So that means E-closure is a set of state which are reachable from Q without taking any input is called as a E-closure. For example, we can take similar example. I need to find out the E-closure of P. So E-closure of P is, how do you get PQRS? Look at that. E-closure of P, Q without taking input it can able to reach Q, and also it can be reached to R to S, right? So that means P, Q, R, S. Without taking any input from P to reach the PQRS. So that is the E closure of P. Similarly, E closure of Q. E closure of R, you can take E closure of R is from here you can able to reach R and S, including that starting point R and E closure of Q. So suppose E closure of Q is Q only. So there is no path after that to reach to any other state on epsilon, the QF. So for that I have defined like this. For E closure of X, it's X itself for remaining 5 state, because Q is Q only, Q1 is Q1 only, R1 is R1 only, S is S1 only, R2 is R2 only. Why that is? We are having only transition on state, on that state itself. We need not to move to the any other state on epsilon. So that's a reason I generalize these states. It will not move to the any other state. Okay, so I think you understand this concept. You can able to find out the E closure of E closure. So then you can also find out the E closure for the particular problems. Now it will let us take the example and apply the definition of X. E closure of Q naught. E closure of Q naught P, then T, right? E closure of Q naught is Q naught P T, right? So that's it. Then E closure of S, where is the S? E closure of S, S, W, S, W, then what is that? It is also go to Q naught, then Q naught, it also go to P, then it will go to T, right? Look at this. S, W, Q naught, P, T, close. Okay. Understand now? So, E closure of S is from S. You can able to reach W, from W to Q naught to P, then Q naught to T. So, this much is the E closure. The applying a delta star. Delta star is also called as a extended transition. Q naught on epsilon, it will go to the Q naught. E closure of Q naught is Q naught P and T, right? So that you need to remember in the previous slide. Now you can understand. So now it is a time to converting from epsilon NFA to DFA. Is it similar to the NFA to DFA? No, it is not similar to NFA DFA, but whatever the step you have applied over NFA from step 1 to 4, it is remains same here. Only thing is need to eliminate the epsilon. How do you eliminate the epsilon? By using epsilon closure. So now epsilon closure to NFA, NFA to DFA. This is a cycle, you can convert it. Also it can be convert from epsilon NFA to DFA. Conversion from NFA with epsilon to DFA. Take down. What are the steps you need to follow? We will take the epsilon closure for the starting state of NFA as a starting state of DFA, which is similar to the NFA, and also find out the transition for each state to find the new state from that. Then again you have to find out the from new state you can find out the new transition for NFA. So this set of state becomes the initial state, set of state become the state of the DFA. Then this step 2 and 3 you have to repeat it as long as you are getting the new state. So once the new state, there is no more new state in the step from the step 2 and step 3, then you have to stop and mark the state of the DFA and also mark the final state which will contain the final state of NFA. Right? We'll take the example. I'll take this example. I have to convert. For before to converting it, you need to find out the epsilon closure. Let us obtain the E closure of each state. Q0 E closure of Q0 is Q0 to Q1, Q0 to Q2. So Q0, Q1, Q2. E closure of Q1 is Q1 itself. E closure of Q2 is Q2 itself. E closure of Q3 is Q3 itself. E closure of Q4 is Q4. So if you do this much you have done, you will get 2 marks in exam. So you need to find out. Now from that you find out the 4 new state. So now you take this first state, which is the initial state. From that you have to find out the new state. Find out. Now let E closure of Q0 is Q0, Q1, Q2 be a state A. Instead of taking entire set, I'll give a further name A. I label it A. So delta of A comma 0, E closure of delta of Q0, Q1, Q2 on 0, you may get like this. You have to split inside that set of state. Delta of A0, Q0 comma 0, union Q1 comma 1, Q1 comma 0, Q2 comma 0. So find out that. So Q0 on 0, there is no transition pi. Q1 on 0 will go to Q3, then Q2 on 0, there is no. So this is pi, this is pi, then finally it is you get the Q3. E closure of Q3 is what? Q3. So which is the new state? You have to label it. So now what is the next new state? So on 1, A on 1, similarly you have to split, Q3 will get, which is same as B, relabel it. Right? Now, so B comma 0, E closure of Q3 comma 0. Q3 comma 0 is, there is no transition, then it is called, that is a pi. So B comma 1, E closure of Q3 comma 1, it will go to Q4, that is Q4. You can, is not same as B and A, then you can rename as a state C. For state C, find out C on 0, Q4 on 0 is pi, then E closure of Q4 is 1. It is also, there is no transition, then you can make that is a pi transition or a new state D. So the DFA will be like this. A on 0, okay, we'll go to Q3, sorry. So you can A on 0 will go to 0 and 1 will go to B. B on 0 will go to D, then B on 1 will go to C, C on 0 and 1 go to D. This is called as a D. Right? Which is the final state now? So which is the final state? C. Why C is final state? C contains the final state of DFA. Right? The NFA. So this is the final state of NFA. This is the NFA. Then it is becomes becomes the final state of DFA. So in this for DFA transition table, this is initial state, C is the final state. So this way it can be converted from epsilon NFA to its equivalent DFA. Thank you. We will do some more problem while I taking a class. This is a one example. I have taken it for pre-video. little you can do some 3 to 4 problems in a classroom, and also you have to practice. Thank you guys. Do you have any doubt? You can raise it in a class. Thank you.